Yeah, so let's see some coding for a change, because I've been thinking a lot recently about my secret project and how to make it like generate landscapes faster, and namely more believable landscapes. Now, this particular algorithm, well, actually, maybe that's the wrong term. Let's say this particular problem I've been trying to solve is like distributory systems, like water flow ways and channels and all that, that sort of stuff. So my first attempt was, well, actually this is not my first attempt, but first modern attempt to try to make it like a driven system, meaning that it does not have to simulate basically much or anything. It can just calculate it straightforward, so there's no back looping, if that makes any sense. Hard to describe, but this let's see if this runs. So this is Berlin noise map, very basic system, and I can move around the map, and those white dots seem kind of random at first, but if I zoom in, they are look like a small rivers. The problem with this system is that it generates these kind of stupid oxbow lakes everywhere, and the way this works is like so anyway, Berlin noise generates this wavy thing. This is now 1D representation of that. So what I do now is like I generate just basic map of that in 2 dimensions, though, and then I take let's say this peak here is at 1.0 and this value is at -1. So I take the 0 level, which is somewhere here, and then I flip these. Anything that goes below, I mirror it, so it goes like this. And this is, then I move the 0 a little bit up. So, or you could think I sink everything down, whatever way you want to think about it. But that makes the, like, those little lakes there. And the result is this. It looks kinda, there are like places where it looks very nice. I mean, this is passable. This would work. But the problem is how to authorize it, so it won't pick or generates place like this. This is not a nice. Well, I suppose that even that could be somewhat realistic, but look at this. So this is like a looping river. Now, of course, all of these actually probably are looping. And yeah, but this is pretty nice result after all. It kind of works, but yeah. Then I thought that what about if I try like using forced particles, those I call it forcell. And this thing was almost, this also uses Berlin noise as the foundation, but now I just decided that maybe I just can generate one branch of the river with all the subsidiaries. Oh wait, that might be wrong word. The like side streams and the headwaters that feed into the larger stream. Now the benefit of this system is that each of these like segments that it generates can be tracked with very high accuracy, and I can attach all sorts of things into them, like how much is there water flowing here, or how deep it is, and or whatever. But this system was very hard to control. As you can see, it's well, there we have some sort of thing. This is not very yeah, I kept messing with it, but with this is the same problem, hard to manage when it generates something usable. Also, it quite often crosses itself, so we have like this small thing here and it curves sometimes back here and like crosses the mainstream, and that's kind of weird. But occasionally it generates kind of believable looking structures, but I was not happy with this, so I kept on going and heard about something called space colonization. Let's actually do that, and let's check out this one. And this was actually quite promising. It needs some work, but also it might not work because it's on random seed, so it might generate nothing. But occasionally it generates a huge system. So let's see how it works this time. Okay, so that was not too big of a system. Let's try again. Hopefully this time it generates something. Okay, so we have something. Yeah, okay, so that's a slightly larger structure, and it looks quite a lot much better. Let's try again. I should have made a restart button to this, but yeah. Let's see. Okay, yeah. Now I'm still not sure what makes these, because sometimes it makes these strange long stretches of. But this also has the problem that it crosses occasionally itself, but way much less than the other one. Let's actually try one more time so we can perhaps get a larger structure. Yeah, there was quite a lot of like crossover in here, so that wouldn't work too well. So how does this work? So this is algorithm or based on, well, it's basically is something called space colonization algorithm, which is used to generate three like structures. It works in 2D space or 3D space. The idea is that you have a bunch of points which act like attractors for something that's moving, and I'm not sure what's the. I adapted it quite a bit because, to be honest, it was kind of confusing, all the documents I found, so I just figured it out myself. And I'm not sure how the branching works in the real thing, but in my case it works each time I call these baits, these dots, is like captured, the branch splits, making a new like two parts. And let's see this in action. Also, once the bait is like catch, it will be removed or marked as eaten. So, and this is what happens. Oh, that's interesting. Pretty cool structure. But yeah, also there's some additional rules. These let's say agents or segments, as I call them. I think they are in the original system called branches, like have certain rules. For example, in that case, we can see these two branch structures started going there, but they could not reach it. And the reason is that each one of these have limited life, and that depends on since when it ate last time, basically, and does it have anything nearby? Because actually that limitation could be, I suppose, a little bit higher. Maybe then we could get some longer structures. Yeah, actually, yeah, that's something I should look into. But yeah, so that's one way of procedurally generating stuff. Yes, it's still kind of messy, but the idea, I think, is starting to show here that you could use this for, well, as it's meant to be, for tree generation, maybe even towns, etc., all sorts of things. Let's have a look at one more time. Maybe we get something nice. Oh, that was so close. So each time one of these captures one of these, its life is reset. So it kind of, yeah, could have been going for a very long time if it had just got a little bit further. So how does this work? Actually, I can even demonstrate it further. Let's take that out, and now you can see just the branches acting. So there's no tracing. It might be hard to see, but let's see. As you can see, there's just one, and we are done. Now I can step this one by one. You can see here is the single branch is calculating. Now in the actual colonization, it's making chain of these, but I use just one agent and trace it later. I mean, like leave a copy of it in the buffer. Well, basically the same thing, but yeah. So this thing might, it got it just barely, and now it's split. That split. Yeah, it's kind of hypnotic to look. This looks if I press complete play, it's like fireworks or something. But yeah, that's something new. Took whole day to get it. Actually, no. Let's put that again back to false and that to false. Also, this is also based on Berlin noise. In the basically, it just uses it to place the original points. That's kind of not necessary, but I like to use it. Oh, that's a pretty nice structure. So yeah, now I should think about how to get rid of these things that go across each other. There might be a way to like check for intersection, and if such thing happens, kill off the branch. But that might take might be a little difficult. Also, I'm not sure if that actually even is a problem. Yeah, let's run it once more just to be amazed. Oh, well, that's a nice example of how it should not do. Yeah, I might have to add reset button to this. Yeah, I think I'm on onto something here. I mean, this needs some sort of like sorting system or something. But yeah, I had real trouble getting the like this curve stuff working. It was. I'm not the best programmer, I know that, but yeah. So let's see actually what happens if I increase that. That means how fast the branches can like move, aim at the next bait. Okay. Also, if I add this, it should allow it to grow out very long. Let's see. Yeah, it's growing very long. Also, there is these strange exceptions when it kind of gets broken for some reason. I'm not sure what happens there. Yeah. Also, this also has the same possibilities as the previous one, as this is like a generated linear structure. I can assign all sorts of values to all of these. Well, in the when I get it like done improperly, because now I'm using just processing to quickly study this algorithm, because this is lightweight way of programming. So yeah, that didn't work out too well. Let's return it to the previous one. What if we make it even harder to see? Huh. Kind of interesting. Got very long. What? Maybe if let's try that. Like very stiff curves. Now that's kind of pretty. Yeah. Maybe the key is to use like very stiff curves. Let's see what happens. Maybe we get a huge structure this way. No? Okay, it did not manage to find anything. Let's try again. What? Yeah, okay. Maybe that's too stiff. Let's see. No luck there. Yeah, also this would be a slight problem if generating for games. You would have to check to have some sort of value to check that at least n number of segments were created. Otherwise, you might end up with empty map. This seems to be kind of stiffening the curve seems to make it very hard to make new paths. Also, let's see if we can. Well, anyway, I'll keep fiddling with this. But yeah, it was a nice thing to try. What the heck was that? And yeah, well, that's not too dramatic. Oh yeah, actually, one thing more. Let's hope it generates something this time. I might have to move that. Did I change something else? Is it stopped now generating? It keeps on doing those. Why? Yeah, well, this is. And suddenly it generates something like that. And that's the beauty of random generation. It's kind of hard to tell what will happen. But yeah, oh yeah, I pressed too far. But this number here actually shows in real time the number of branches active. Let's try to regenerate, and maybe you can, maybe it shows some numbers. It's probably not too big a number, but let's see. Yeah. But yeah. Yeah, so that's what's happening now. See you other time.